So today we are going to take a look at section 7.8, which is about factoring polynomials completely. And that will lead us to some very interesting problems that will require us to put together everything we've learned so far. And in this particular problem, we are actually not just asked to factor this, but rather we are asked to solve the given equation. Let me move this over a little bit so you can actually see that. There we go. We're asked to solve this equation. And we're given 2x cubed plus 8x squared is equal to 10x. And in order to solve this equation, we must begin by moving our 10x over to the side that already has our x cubed and x squared terms on it. And I will do that by subtracting 10x from both sides. That will leave us with 2x cubed plus 8x squared minus 10x is equal to 0. And from here, we are now capable of going through and solving this. So after the slightly annoying step of needing to subtract 10x, we now need to begin our factoring. And the first factoring we always need to check for is factoring the greatest common multiple. And when we look at this, I'm first going to draw my parentheses in, and then we'll fill it out as we go. When we look at this, and we'll first start by looking at the x's here. We have x cubed, x squared, and x. That means that this one has x times x times x, this has x times x, and this has an x, meaning we can factor one of those x's out. In addition to that, when we look at the coefficients, the numbers attached to the x cubed, x squared, and x terms, we can see that we have a 2, an 8, and a negative 10. All three of those numbers are divisible by 2. So I'm going to go ahead and factor a 2 out. So our 2 comes out. 2 divided by 2 is 1. So we no longer have a coefficient on our first term here that needs to be written out. But since we've taken a 2x out of 2x cubed, we simply have x squared left. In our second term, we took a 2 out of the 8. So since that was divided out, we're left with a 4. And since we no longer have x squared, we just have a singular x. And likewise, on our negative 10x, we took a 2 out of the negative 10, leaving us with a minus 5. And we divided the only x that was there out, so there's no x's left on that part of it. Now we need to look at our trinomial that's sitting inside our parentheses here and figure out if we can factor it. And looking at this, this has a coefficient of an a equal to 1. So I'm going to write these over here. A is 1, B is 4, and C is our negative 5. So our A times C in this one is going to be our negative 5. And our B is equal to 4. So we need to choose factors of negative 5, which add up to 4. And what's so convenient about a number like 5 is its only factors are 5 and 1. And since our B value of 4 is positive, that means that our 5 should be positive and our 1 should be negative. And you'll notice that 5 minus 1 does in fact equal negative 4. And obviously 5 times negative 1 is equal to negative 5. So we have our factors here. They are 5 and negative 1. And because our a value is equal to 1 in this particular problem, we can go ahead and use that shortcut that we learned in 7.6. And we can write our factors as being, we still have our 2x sitting on the outside. Our first factor is x plus 5. And our second factor is x minus 1. And this is all equal to 0. So at this point, we can solve for our x's. And we do that by taking each of the 3 factors that are written here, setting them equal to 0 and solving. So our first factor would be 2x is equal to 0. And let me move the piece of paper up. 2x equals 0. We divide both sides by 2. And we're left with x is equal to 0, as 0 divided by 2 is 0. In our second factor, we have x plus 5 is equal to 0. From here, we can subtract 5 from both sides, giving us x is equal to negative 5. And likewise, with x minus 1 equals 0, we can set both of them. We can add 1 to each side and get x is equal to 1. So we can say that our solutions to our initial equation way back here at the beginning are x is equal to 0, x is equal to -5, and x is equal to 1. As in this problem, we had to use factoring out greatest common factors, and then we were able to factor a trinomial with an a value equal to 1.